Hello, my name is Stephen Baker, and the STEM topic that I have a passionate interest in and that I would like to talk today about is nothing less than rocket science. More specifically, aerospace engineering, a field of engineering that has continually pushed the limits of human ingenuity and continues to do so today. From Sputnik 1 to Dragon V2, the design of spacecraft and their missions have given us unprecedented knowledge and led to a great number of technological advancements. A few of these advancements include LEDs, infrared ear thermometers, artificial limbs, highway safety, improved tires, chemical detection, landmine removal, firefighter gear, solar power, and even water purification. These improvements and inventions all came from either the development of spacecraft, knowledge gained from their missions, or the inventions required to sustain human beings in space, which, as you might imagine, is not a simple task. But before we leap to the future, let's take a quick look at the history of this impressive field. After the Soviets beat America to space with the aforementioned Sputnik 1, President Kennedy turned everyone's attention to the moon and announced that America would land on the moon before 1970, hailing the Apollo program, which, of course, did succeed in its mission in the famous Apollo 11. But that was far from the end of NASA. In September of 1977, Voyager 1 was launched and has done detailed surveys of Jupiter, Saturn, and a Saturn moon called Titan, and still transmits data today as the farthest man-made object from Earth at a distance of around 10 to the 10th miles away, which is about 137 times the distance from Earth to the Sun. Another famous spacecraft is the Hubble Space Telescope, launched in April of 1990, which has given us more than just fantastic photos of deep space, but also led to breakthroughs in astrophysics, such as accurately determining the rate of expansion of the universe. Another spacecraft that may sound familiar is the International Space Station, which, frankly, sounds as if taken out of science fiction, and is currently host to 6 astronauts who just did 100 days in space. The record, however, is 340. The first component of that was launched in '98, closely following the launch of the impressive Cassini-Huygens, which shows an impressive resemblance between Titan and Earth in terms of geological features. Originally, it was not feasible for anything but massive government agencies to develop and launch spacecraft. But after consistent budget cuts to NASA around the end of the millennium, private companies such as SpaceX have taken it upon themselves to continue the exploration of space and came up with a way to reuse nearly all of a rocket's parts, cutting costs dramatically. Currently, SpaceX acts as a courier for supplies, cargo, experiments, and satellites into orbit or to the International Space Station, utilizing the Falcon 9 rocket and Dragon spacecraft. Dragon V2 is designed to ferry humans and will be carried by the Falcon Heavy, which will hopefully make its maiden voyage this summer. SpaceX's grand vision is to establish a human colony on Mars, with missions to help begin such a task as soon as next year with the Red Dragon missions. Other similar competing companies include Virgin Galactic, hoping to offer commercial spaceflight in the near future. But if humans ever want to explore outside of the solar system, a whole new type of propulsion is necessary. The nearest star to us is Proxima Centauri at 4.24 light-years, or the distance light travels in 4.24 years. To put this into perspective, it would take Voyager 1 73,000 years to travel this distance at its current rate. The answer to this problem may currently lie in science fiction. So when an antimatter particle collides with its matter counterpart, they annihilate each other with 100% efficiency, turning all of their matter into energy, according to Einstein's famous equation E equals mc squared. Now, that's a lot of energy. Nuclear reactions and atom bombs turn only 3% of their mass into energy, making it no surprise that the Enterprise from Star Trek utilizes a matter-antimatter reactor as fuel. There's only one problem. Antimatter is virtually impossible to find, synthesize, or store, making it difficult to use as a power source. But as humans continue to push the boundaries of science fact, it may one day become a reality. Now, while all of this is fantastic, it may seem difficult to get involved in the infinite expanse of space without a degree in aerospace engineering, which is what I plan to do with this scholarship. But in fact, it's relatively easy to get involved. There's a load of projects that absolutely anyone can be a part of, many hosted by a site called Zooniverse, in which you can look at pictures of planets or deep space and help identify objects of interest. Another is entitled SETI at Home, which utilizes your computer's idling time to sort out electromagnetic signals and search for extraterrestrials. If you're looking for a more hands-on approach, you can join a NASA-hosted contest to help them find creative solutions to difficult space problems. As for myself, I plan to keep building rockets until one of them finds its way to the edge of the universe, and then beyond.